Welcome to the AWS Innovate Online Conference. My name is Luke Anderson and I'm part of the Storage Business Development team. Today I'm going to be talking about AWS services for data migration. I'd like to start with an overview of the storage services we have available in AWS. As you can see, we have block, file and object store offerings in the center of the screen. For block storage, there's Amazon Elastic Block Store, which I'll refer to as EBS for the remainder of this presentation. EBS provides block storage for EC2 instances running inside of AWS. For file storage, we have Amazon Elastic File System, which I'll refer to as EFS for the remainder of this presentation. EFS is our NFS-based scalable file system that provides file services via NFS to workloads that are running inside of AWS. And with one of our recent releases, we provide the capability to connect your own data center file systems to EFS, and we'll talk about that a little bit later in the presentation. And then at the bottom of the circle, we have Amazon S3 and Amazon Glacier, that I'll refer to these as S3 and Glacier for the remainder of this presentation. S3 and Glacier are AWS's object storage offerings that are foundational to moving workloads into AWS, including large data sets and used in building things like data lakes and compliance archives. Amazon S3 offers a range of storage classes designed for different use cases. There are 4 highly durable storage classes, including Amazon S3 Standard for general purpose storage or frequently accessed data, Amazon S3 Standard Infrequent Access, or Amazon S3 One Zone Infrequent Access for long-lived but less frequently accessed data, and finally Amazon Glacier for long-term archive. The AWS object store offerings provide 11 nines of durability, which means if you store 10 million objects with Amazon S3, you can on average expect to incur a loss of a single object once every 10,000 years. So we're going to focus on today is the AWS Storage Gateway, or Storage Gateway, the Amazon EFS File Sync service, or EFS File Sync, that we launched back in November, as well as Amazon S3 Transfer Acceleration, and finally, the AWS Snow services. As you start to think about moving to the cloud, migrating your data, application and workloads, it is good to understand why many companies are doing this today. First, to have infrastructure that is more cost-effective, by only paying for what you're using and not having to go the traditional route that we've seen with storage arrays in the past, or even compute in the past, where organizations try to guess what they're going to need in the future, say 24, 36 or 48 months out, and then buy it all up front. Which means from a storage perspective, you're paying a lot of money for capacity that you're not storing data on because you bought many years worth of storage. Albeit, over time, the cost per gig is going to go down, but up front it's fairly expensive and there's a lot of heavy lifting that you have to do to put that infrastructure in place. Plus, you're paying for facilities, power and cooling to have that surplus capacity sitting idle in your environment. By not having to worry or spend time capacity planning and procuring your infrastructure, you create productivity gains in your workforce. This is coupled with the agility and elasticity benefits of moving into the cloud, and being able to add new instances or add more storage on demand creates capacity in your workplace. AWS lets you quickly spin up resources as you need them, deploying hundreds or even thousands of servers in minutes. This means you can very quickly develop and roll out new applications, and it means teams can experiment and innovate more quickly and frequently. If an experiment fails, you can always deprovision those servers without risk. So when moving data into AWS, there are some things you need to think about up front. Planning up front is critical to enable the best experience for your end users and your customers. While every cloud adoption journey is unique, all require a data migration step, which can be hindered by blockers. The first is we want to think about things like disruption from migrating a data center or application or workload that can impact your customers and internal stakeholders. For instance, if you are migrating a file share, you want to ensure dependent users have been notified and aware of the change. Next, the speed for how quickly you can get the data there, and we'll cover that a little bit later. Certainly the costs associated with migrating data, especially if you have to put in additional network circuits to be able to move the data up front very quickly, or to do a bulk data move. Last but by no means least are things like cloud compatibility. You want to make sure that your applications are going to run correctly and that you're not going to have any issues. So, 5 key questions to ask yourself before you start to migrate data. The first thing is, what kind of data is it? Where are you going to put it? We have database object and file block endpoints, so you have a lot of options to choose from, and you want to make sure that you're getting the data in the right optimal place. For example, if you're moving a database that's a SQL database, you might be able to move it directly into one of AWS's managed database offerings. Then you don't actually have to migrate the application that's running that database. You could just move the database and have it run and be managed and protected on AWS without having to refactor the tool. So we want to make sure we get the right data. The next question to ask is, are you going to do this one time? Is it one large migration or is it ongoing? Are you going to continue to replicate data in? We certainly have a lot of customers that move data in on a continuous basis, and they're processing it inside of AWS. They're getting to their desired results much faster because they can spin up more EC2 instances as required, or use services like Amazon EMR to process all of the data in a rapid fashion. The next question, is this a one-way migration or is it going to be bidirectional? If you're doing a data center migration into AWS, then that's a one-way, as you're moving all the data and it's going to live inside of AWS. If it's bidirectional, that means you're going to be moving data into and out of AWS on a regular basis. An example is that we have customers that maintain research environments on-premise. So if you think about a biotech or a pharmaceutical company, you have chemists, scientists, and researchers all generating large amounts of data and moving that data up into AWS. Then they're processing it inside of AWS, maybe on EC2, Amazon EMR, or other AWS analytics services. And then the results are getting saved back into S3 to be read back onto their on-premise applications and instruments. Number 4, how much data and time do you have? This goes back to what the network looks like. If you're going to do a continuous migration or a one-time migration, and how much data do you need to move at a time? And what's the time frame for when you start to when you want to be up and running inside of AWS? The last question is about the WAN, or the Wide Area Network. If you're running over a Direct Connect and running over the public internet, you'll probably have an MPLS circuit and coming in via VPN. You want to think about network connectivity between your data center and AWS that is going to affect the 4 other questions in this list, because if the WAN isn't large enough and you have a very tight time frame and a lot of data, you might start running into issues trying to transfer that over the network. The good news is that AWS has tools that can help you manage that process, and we'll cover that later. I want to talk for a minute about AWS Direct Connect. AWS Direct Connect, or Direct Connect, is a way for you to connect your data center or your large regional offices or remote offices into the AWS infrastructure via dedicated connections. With Direct Connect, you get 1 gigabit, 10 gigabit, or multiples of 10 gigabit links. With a direct connection, you're not going over the public internet, you're going over a private network. And this is going to give you the lowest latency possible. I say possible because you can't overcome the speed of light or distance, but you can get a little bit better control about the path the data is taking over the network. For example, you gain some efficiencies by reducing the amount of packet loss and congestion that you'll typically see going over the internet. With Direct Connect, you get a secure, high-performance connection into AWS that many of our customers are using today. The next thing we're going to talk about is the AWS Snow services. The AWS Snow services are made up of AWS Snowball, AWS Snowball Edge, and AWS Snowmobile. With the AWS Snowball, you get 80 terabytes of capacity, 10 gigabit network connection, and when you copy data and write data into AWS Snowball and the AWS Snowball Edge, the data is going to be compressed and encrypted. An important thing to note is that the encryption key doesn't travel with the device. That means you keep control of the encryption and the data. You control the writing of the data to the device, and once we get the device back, we're going to verify that it hasn't been tampered with by using established external tamper checks. We're also going to verify that the operating system and everything electronically about the device is secure and hasn't been tampered with. Once that has completed successfully, we're going to copy all of that data into your S3 bucket. So with the AWS Snowball Edge, you have 100 terabytes of capacity, and we have 10, 25, and 40 gigabit network connections. You also have the ability to write to the AWS Snowball Edge via NFS clients, and it also has its own S3-like API, So if you have an application in your data center that supports S3 API, you can write directly to the AWS Snowball Edge using that. With the traditional Snowball, you have a client that acts as an S3 API, which can copy the data and write it into the Snowball for you. On the far right of the slide, we have the AWS Snowmobile. This is our exabyte scale device. When you order the AWS Snowmobile, we'll drive it to your data center, you plug it in, you fill it up with data, and then we'll drive it back and load all of that data into your S3 environment inside of AWS. So the AWS Snow services are a way that you can move large amounts of data without having to saturate your WAN, or if you have a location where the WAN quality isn't that great, you could send an AWS Snowball or AWS Snowball Edge there. The thing to remember is when you're moving large amounts of data and you need to do it quickly, the AWS Snow services are a way for you to be able to do that. To get the process started is pretty straightforward. You log into the console and create a new job. We will then ship the device to you, you receive it, you unlock it, and you plug it into your network, and then you fill it up with data, and then ship it back to AWS. And again, after we verified that everything looks good and secure, we'll then copy that data into your S3 bucket. The next thing we're going to talk about is Amazon EFS File Sync. With EFS File Sync, you can move data from your file systems inside your data center or your regional offices into Amazon EFS File System. And you can do it very quickly, very easily, and securely, as everything is encrypted end-to-end as you're moving the data. How it works is that you deploy a sync agent inside your data center or your regional office. This sync agent runs in a virtual machine as seen on the left-hand side of the slide. The virtual machine connects via NFS to your file server or NAS device. Then you'll have an NFS export of a file system that you can copy in its entirety, or you can connect directly to a subdirectory and just move this subdirectory to EFS. Once the connection is established, we'll move all the required data off into AWS. Again, we do that over an encrypted connection that is also compressed prior to transfer. We do this using multiple TCP flows with an AWS developed TCP stack that has been tuned for high throughput and to be able to deal with things like packet loss and packet out of orders, typically things you're going to see if you're going over a VPN connection over the internet. This enables you to get the highest possible performance when migrating those file systems. And now let's see this in action. So we start the demo with two Amazon EFS environments created in US East 1 and US East 2. Now this could also be with an on-premise NFS file system connecting to an Amazon EFS file system. The Amazon EFS file sync agent has been deployed onto an EC2 instance. So we're going to create a sync task in the Ohio region. We capture the DNS name for the source file system and enter that in. Then we specify a source mount point, and in this case /source. And then choose the agent required, which is the Ohio region. And now we go and perform the same tasks for the destination, where we select the mount point, in this case it's /destination. In the sync settings, you can select whether you preserve some of the metadata, for example, ownership, permissions, and whether you want to keep consistency between the source and destination file systems. Now we name the sync set, Ohio to Virginia. We can now see this being created. Once we've refreshed, we can see the sync set will be available. Now we go up to Actions and we start the sync task between Ohio and North Virginia. The status will say starting, and then we'll start to move to a percentage complete as we move through. There are multiple stages to this. Once it's working through, it will start performing a verify, and then it will say completed at the end. Now let's just check the History tab to make sure the 17 files have been migrated across. As we can see, the best way to check this, let's just log into the systems. We're on the source system at the moment. We check that we're in the /source directory. We do a quick df to check the file systems, and then we're going to do a list to see the 17 files that we have in our source. Now we're going to perform the same commands across on the destination file system. Again, we'll check our current directory, check the file systems, and then finally we'll do a listing just to see that we have actually migrated and synchronized the 17 files across and preserved the permissions and sizing. The next thing we'll talk about is Amazon S3 Transfer Acceleration. Amazon S3 Transfer Acceleration is a way to improve performance when you're writing data to or reading data from S3 buckets that may be far away. So in this slide you can see we've got an S3 bucket inside US East 1 on the east coast of the United States, and we have a client in India who is uploading data into an S3 bucket. Doing it the traditional way, you'll be going over the internet where you'll have high latency as you're going over long distance and going over the internet. In this scenario, you're also highly susceptible to packet loss and packet out of orders, which is all going to reduce the performance. So even if you have a 1 gigabit network, you're probably only going to average about 4 megabits per second and have hundreds of milliseconds of latency. Even if you have as little as 1/10 of 1% packet loss, it's going to dramatically slow down the performance. So S3 Transfer Acceleration is a way for you to get around those issues of going over the internet. The way it works is the client makes a connection to one of AWS's edge locations that is part of the global Amazon network. In this case, they're connected to an edge location that's inside of India. So now instead of a connection that is hundreds of milliseconds, it's significantly reduced. The data is terminated at the edge location and then transferred over the Amazon network where we have no packet loss. We can manage congestion as well as do things like manage the window size for TCP and take advantage of the bandwidth available. All of this is automatically performed and there's no software required. You simply enable it for the S3 bucket via your console and then add S3 Transfer Acceleration into the URL for the bucket. All of this, as with other AWS services, is documented in the online user documentation. As discussed in the previous slide, we've seen customers experience up to 171% improvement in transfer speed by using S3 Transfer Acceleration. And as you can see, the further away you are, the better the delta in performance. Now for a customer use case for S3 Transfer Acceleration. Huddle is a software provider that offers video and analytics platform for coaches and athletes to quickly review game footage to improve team play. The web-based system serves youth, amateur and professional teams in football, basketball, soccer, volleyball and other popular sports. The problem statement is that on a typical Friday during the football season, more than 35 hours of video is uploaded every minute. They implemented S3 Transfer Acceleration to improve the upload speed for coaches after their sessions, and they saw a 20% increase in upload speeds. You can find out more details on the AWS site under Case Studies for Huddle. Next, we're going to talk about the AWS Storage Gateway family. The AWS Storage Gateway family enables you to build hybrid storage solutions when you're connecting infrastructure, applications, and servers inside of your data center to AWS. This enables you to take advantage of the durability and low cost of S3, the low-cost archiving capabilities of Glacier, and the data protection with things like Amazon EBS snapshots for volumes of data that's running inside of your own data center. We break down the AWS Storage Gateway into 3 modes. So on the left-hand side, you see that we support files, volumes, and tapes. On the right-hand side, you see that we support targets such as S3, Glacier, and EBS snapshots. An important thing to note about the AWS Storage Gateway family is that all modes support AWS CloudWatch, AWS CloudTrail, AWS IAM for security management, and AWS KMS for encryption. So if you're using AWS today, the same tools you use to manage and operate your AWS environment can be used with the AWS Storage Gateway. The first thing we'll talk about is the File Gateway. The File Gateway provides an on-premise file storage solution that's running on a virtual machine inside of your data center. It's exporting NFS version 3 and version 4.1, which means that your Linux and Unix workloads and also some of your Windows workloads can connect. We then have an HTTPS connection back to the Storage Gateway infrastructure in AWS that connects to S3, S3 infrequent access, as well as Glacier through lifecycle policies. So when you connect the File Gateway virtual machine to an S3 bucket, you can have up to 10 buckets connected to that virtual machine for the File Gateway. So each bucket becomes an NFS mount point that enables you to choose where you write data into and whether it lands on S3 standard or S3 infrequent access, and then enables you to take advantage of the lifecycle policies. So with all the flexibility you have with an S3 bucket today, you've got with the File Gateway, because all the File Gateway is doing is presenting an NFS export or NFS mount point to that S3 bucket. It's important to know that all of these storage gateway modes provide a caching layer, where you can have up to 16 terabytes of cache for a virtual machine, which means that any data that writes to the storage gateway is going to be stored locally in cache. This enables you to get a fast response back to the application server. Then in parallel, the virtual machine is going to start streaming the data up into your service in AWS. So for example, if you were to write word.doc to the File Gateway, you will see this in your S3 bucket as an object named word.doc. And if there's a directory structure, say it's users/luke/mydocs/word.doc, we'll take that directory structure and we'll turn that into a prefix for the object when we write it into your bucket. So this means you can migrate data from your application servers inside of your data center, put that data in S3 that enables you to perform real-time SQL queries using Amazon Athena or process it using Amazon EMR. Now I want to share a use case with you for the File Gateway. So this is Halliburton Landmark Services. Landmark provides services, software, and data center applications to companies in the oil and gas industry. Landmark was storing oil field data, seismic data, satellite imagery on NAS filers, and they were archiving into LTO drives and then sending them to tape offsite for long-term secure storage. Now, when a customer came to Landmark and requested this data, Landmark would then have to request the tapes back from offsite. They then have to restore them onto the NAS filers, and once the data was back on premise, they would then provide the application data to Petrobank, which is their application to their end users. Only then could the end users access the data requested. So how they fixed this with AWS was first they copied their data to a snowball and shipped it to AWS, and then we put it into their S3 bucket. They then deployed a File Gateway inside of their data center and connected that to the Petrobank application to the File Gateway. As they were already using NFS to mount their NAS filer, it was a simple process to migrate the connection to File Gateway. Now they're able to go from days and weeks to restore the data and make it available to their customers into a real-time self-service model. Not only have they been able to reduce this time to data for the customers, they have reduced what they were paying for archiving and managing that archive by up to 90%. So next we're going to talk about the Tape Gateway from a migration standpoint. Tape Gateway fits into a couple of different use cases, and after I've explained how Tape Gateway works, we'll walk through an end-to-end workflow of how you would migrate data using the Tape Gateway. The Tape Gateway presents 10 drives, 1,500 slots, and a robot as part of Virtual Tape Library. So you connect to it via iSCSI, so your system's existing backup software is able to go through and index the library. You then create tapes as they're needed on demand and up to 2.5 terabytes per tape. One thing that's important to know about the Tape Gateway is that when you create tapes, you only pay for capacity that's used. So you could go ahead and create 100 2.5 terabyte tapes, barcode them, but only write 1 gigabit of data to those tapes, you would only pay for 1 gigabyte. So as with all AWS services, you're only paying for what you're actually consuming. But you can go ahead and create all of those tapes in advance so that you're ready on your backup application when required. So as I mentioned previously, the Tape Gateway also has a local cache. With the Tape Gateway, you can have up to 16 terabytes of cache. And what that means is if you're backing up 10 terabytes, that entire backup will fit in cache. If you needed to restore data, you're restoring directly out of cache, at least until you do the next day's backup. All of your data gets stored inside of AWS in the back-end component of the Storage Gateway. However, with Tape Gateway, to view the data stored in AWS, you have to go through the Storage Gateway service, as we do compress and encrypt the data before it traverses the network. So how it works with AWS Tape Gateway is for all data that is written to a tape in the drive, that same data is written to S3. So if the tape is still active in the library, that means that inside of the Storage Gateway service, that data is stored in S3. If you export a tape out of the library, the data gets lifecycled automatically to Glacier as an archive, similar to how you would do this with your traditional backup software. So it's the same workflow that you have today for writing tapes and managing tapes, but using AWS. As discussed earlier, here is a quick example of a workflow. You have a backup server writing backup data to a disk appliance, and you have a tape library for archiving on-premise. Then you're sending those tapes off-site into a vault for longer-term archiving. First, you deploy the Tape Gateway virtual machine. You connect to the service and configure the backup server to connect to the AWS Storage Gateway via the VTL, Virtual Tape Library. Now the backups are being written to Amazon S3 and then archived across to Amazon Glacier. You can now stop writing to the tape infrastructure and utilizing the offsite vault. Typically, all of those old tapes are going to expire at some point over time, so you can stop adding to that stack, stop buying physical tapes, stop making archive copies or clone copies into your tape library, and maybe have to keep your backup disk appliance because that could be doing things like deduplication. And over time, your old tape archives are going to start to expire. And as they expire, you can take them out of your backup software and out of the offsite storage. Over time, you'll be able to completely remove all on-premise storage infrastructure and have all of your backups going into the Tape Gateway virtual machine. So Tape Gateway provides a mechanism for you to migrate your data out of old archive into AWS, preserving the workflow that you're using today. The next thing that we're going to talk about is the Volume Gateway. The Volume Gateway is volume storage presented over iSCSI, where you get an iSCSI LUN, just like if you had a SAN storage array. Just like with tape, it's compressed and encrypted and then sent over an encrypted connection to AWS. It's stored in S3 as a volume, and here you can take snapshots using the EBS snapshot service. You get up to 16 terabytes of cache inside of that virtual gateway, and we have two modes with this cache. The first mode is cached, and with cache mode, you get 32 times 32 terabyte LUNs, which represents 1 petabyte of addressable storage capacity back inside of the service. And you can mount that from any server, workstation that supports iSCSI and start working with it. The second mode is stored volume mode, where we keep a copy of all the data on the LUN inside of the virtual machine. With the stored volume mode, all of the data is going to be stored in that virtual machine. That means all of your writes and reads are going to happen to and from cache inside of the Storage Gateway virtual machine. And where this becomes interesting from a migration standpoint is that you can use this to migrate existing data out of your data center. So as you can see on the left, we have an application server where we have an existing volume where this would be likely mounted over a storage area network. To use the Storage Gateway in stored volume mode as a migration tool, you would deploy the virtual machine inside of your data center. Then take that volume, you detach it from your application server, and you attach it to the Storage Gateway virtual machine. Inside of the Storage Gateway virtual machine, we're not going to rewrite any of the data. We won't format it, and we're not going to write a new disk signature. Everything will stay as it was, and your application server is now going to connect to that LUN via iSCSI, and everything will look as if it did when it was connected natively. But now the Storage Gateway virtual machine is in the data path. Next, we're going to take that data and we're going to start bootstrapping it, which means we're going to start copying it in aggregate blocks up into the Storage Gateway service to create a new volume. Once the new volume has been created, you can take a snapshot. And when you take that snapshot, this is where you can migrate that data and that workload up into AWS, because once the data is done bootstrapping and we take our snapshot, it is an authoritative copy of your application data. We can deploy a new EC2 instance, and in this case, a Windows server. We can take that snapshot, and as it will be an EBS snapshot, which means we can turn it into an EBS volume, we can give it to that server we've just spun up. Now you can take away other infrastructure and have all of your data and application server where it's been migrated to up running in AWS with minimal amount of downtime and the minimal amount of overhead and efforts to actually get the data and the application running up into EC2. So now to finish up, I do want to point out the AWS Partner Network. So today I've talked mostly about AWS solutions for migrating data to AWS, but we do have a very rich partner network who extends some of our existing services. So you'll see data migration, the second column there on the left. Those are all partners that can provide services to move data into AWS. Then to the right, we have partners that specialize in things like archive, even building primary storage systems on top of AWS through to business continuity and disaster recovery. So you can look to our partner network to provide not only services, but even solutions that we don't provide natively at AWS. Finally, the last thing is that we have storage training available. So if you go to aws.training, you'll be able to find and go into courses, get deep dives on things like S3, EFS, EBS, and Storage Gateway. To gain more confidence and hands-on experience with AWS, you can access the digital and classroom trainings built and delivered by AWS experts. AWS also has a wide partner ecosystem to help you focus on your success and take full advantage of all the business benefits that AWS has to offer. To learn more about APN partners and find the right one that fits your needs, please visit the AWS APN booth at our showcase. Finally, I'd like to thank you for attending today and sticking it out until the very end of the presentation.